everybody, this is Mrs. Wild from your WCA Earth Science B class, and I'm going to do a video tutorial on how you need to do your comparing carbon loads lab report. I've made some modifications from what is in the lesson for this, so just make sure you are paying attention and doing those modifications. So the lab report looks a little bit different. I've changed a few of the rules and a few of the graphs and stuff within here, so make sure you are using my copy that is found on the intro page, which should be a link right above my video. So you can use a regular dice from home. um, I thought it would be easier to use a virtual dice here, so I'm using free online dice. And we can just click the button to roll the dice above this lovely ad of some beautiful office chairs, much nicer than anyone that I'm sitting in currently. So what we're doing is we're pretending that we are basically modeling the movement of a carbon atom through the carbon cycle. So we can kind of pretend like we are an atom of carbon. And there are some rules to determine where we're going to go in the carbon cycle. Kind of depends on whether or not this was back in history prior to the Industrial Revolution. We had more plants because remember, before kind of deforestation, there were fewer people and fewer animals on Earth at the time. And we didn't burn as much stuff. We didn't have cars, we didn't have factories, so we weren't doing as much burning of fossil fuels. Today, we have less plant life. We've destroyed a lot of forests and stuff like that for agriculture and for wood and those types of things. And we have more people on Earth, more animals for livestock, and we burn more stuff. So the rules are different from before the industrial revolution to today. So we're going to pretend that we always start, or the carbon atom always starts in the air. And what happens to the atom is determined by the roll of the dice. The rules are different though. It depends on kind of what's happening. So if we start in the air, then if we roll a 1 or 2, we stay in the air. If we roll a 3, we go to the ocean. And if we roll a 4 to 6, we move to the plants. And we'll continue to do this for 3 full cycles. So the first cycle will start in the air, and then we'll roll the dice to see where we go next. And we'll finish this cycle when we get to the end of this row here. So let me go ahead and roll. And I rolled a 4. So according to my rules, I'm in the air. A 4 means that a plant has taken me in through the process of photosynthesis, and now I am becoming sugar in a plant. Oh, that's so nice. And then I roll the dice again, and I get another 4, but now I'm in the plants. And so that tells me that I'm going to go back to the air. The plant has maybe given me off during respiration. I'm not sure, but I'm moving back to the air. I'm going to roll again, and that puts me at number 5. And number 5 means I am going to move again to the plants. All right, that's okay. It's a nice place to be. And then I roll the dice yet again, and I'm at number 3. If I'm in the plants, that moves me back to the air. So I've literally just moved from plants to air and back again. That's okay. And I end this round, okay? And I'm going to start, you always start the round in the air. So now you need to do is you need to roll your dice to determine what happens to you in round 2 and again in round 3. And remember, you're always starting the round in the air. When you're done, you're going to tally up each of the columns and put it under your sum column, okay? Then you're going to say, okay, now let's say I'm post-industrial revolution. Again, you always start in the air, but the rules are different. So if I roll number 3, I stay in the air. I haven't moved. So if you roll anywhere from a 1 to 4, you stay. So go ahead and stay in the air. Oops, that's the wrong chart. Down here. Okay. Or let's roll again. I rolled a 2. Well, I know I stay in the air if I roll a 2 because it said 1 to 4. I'm staying in the air. Okay. Let's roll again. I now have a 5, and from these directions, it says I go to the ocean. So through the process of diffusion, the ocean has taken me in. Ocean is all the way over here. I'm off the screen a little bit because I'm kind of running out of space, but now I'm in the ocean, and I rolled a 1. And according to my new rules, that means I stay in the ocean, okay? I like the ocean. It's nice and, wet. And that marks the end of the first round. So now you need to continue on. And you don't have to use my numbers, by the way. You can start over from any one of these, but you still need to complete rounds 2 and 3 for those post-industrial revolution numbers and those rules, right? Once you're done with that, you're going to construct a graph. This is where I've kind of changed, especially from the original, because I find it easier to do these side by side. You're going to use the numbers in the sum. So we haven't done any of that yet, but let's just pretend that we have, I don't know, we already have 1, 2, 3, 4, 5, maybe, we end up with 7 here. Maybe in plants, we end up with 5. Maybe in animals, we end up with 3. Maybe in soil, these are just like made up numbers, so don't use them. In soil, we end up with 2. Maybe fossil fuels, we end up with 4. Maybe ocean, we end up with 3, right? If that was the case, then I'm going to use those numbers down below. For air, I'm going to go up to the number 7. And according to the top here, blue is pre-industrial revolution. So I'm going to use the little paint bucket, and I'm going to fill that with blue. Okay. And then let's see, plants is, we had 5 from our sum. Again, made up numbers, so don't use those numbers. Oh, or am I out of order? No, ocean should be next. So we had ocean was what? 3? 3 was our sum? Yeah. So we're going to go ahead and use that. 3. Paint bucket, again, blue. And you're going to do that all the way across. And then right next to it in orange, you are going to do whatever your number is post-industrial revolution or today, okay? So we can compare them side by side. So hopefully that makes sense to you, because I want to have like a double bar graph all the way across that you can compare the past to the present. And then you just need to answer questions. And I want you to think about a few things. So how do they compare to each other? So that means how are they similar and how are they different? So you're kind of evaluating, so compare and contrast, right? Then you're going to look at the rules. And this is really where the kind of main point of this simulation comes into play. When we look at the rules, it's going to say the rules are different. Oh, schnookers. I forgot to make a copy of this. So you're going to have to make a copy, because right now I didn't make a copy. And as you can see, other people are using this document right now, and I don't want to mess that up. All right. So you're going to compare the rules to each other. Basically, why would it be more likely? So we have, if you roll a 1 to 4, it's going to stay in the air. In the past, it was only a 1 to 2. So why do we have more numbers that represent air today? Like, what are we doing different today that would put more carbon into the air? Okay. And what was different in the past where there was less carbon in the air? Why is it that we have more that would go to plants in the past, but less with plants today? So those are the kind of rules that we're looking at, right? It would be more likely that plants would take it in the past because there were more plants. So think about what happened, what was life like then versus now, and how does that reflect in the rules? And then, let's see, there's our graph that we already did. Now you're going to think about it in regards to climate change. So what has been the major change in the carbon cycle pre-industrial revolution to today. How are we affecting it? If I constructed another graph or another like set of rules for the future, how might those rules change? Maybe, how might you change the roll rules? And what do you think would happen? Like, where would we find more carbon in which reservoir in the future? And then what human activities would be causing these changes? Says, what human activities could redistribute carbon loads in the cycle? How might we change it so that global warming would increase, or how might we change it so that global warming would decrease? So explain the process and how it would affect global warming, human activities. Explain the human activity and how it would affect the processes, and then how would that change, increase, or decrease global warming. And that's pretty much the extent of this portfolio. So hopefully that helps you kind of figure it out. If you've got questions, let me know. Otherwise, thank you so much for listening and have a great day.